Ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, my name is Eric Cavanaugh. I will be your moderator for the second event of our 2013 schedule. Very excited, looking forward to a long year of good content and great discussions with our analyst friends and, of course, all the vendors out there doing interesting things. So let's go ahead and jump right in. So there's a slide about yours truly, and enough about me. The mission, as many of you now know, of the briefing room is to reveal the essential characteristics of enterprise software. We're really trying to give you out there as users of these technologies as clear a view as we can of what they are, how they work, what they do, why they were designed a certain way, for example, and, for example, also what they don't do necessarily. A lot of times, people can get an impression about what a particular software application can do, and maybe it's not always completely accurate. So what we do here is we basically position analysts with vendors, and we reveal for you a live analyst briefing. So one of the rules is that the analyst and vendor do not coordinate before the show, and the reason there is because we're trying to preserve that natural kind of conversation that occurs when an analyst takes a briefing from an innovative vendor. So here are the topics coming up. February is going to be analytics. March is open source and that whole Hadoop thing that I'm sure you've all heard about. April is intelligence, and this month, of course, is big data. Goodness gracious, we hear all about big data these days, and there are plenty of reasons why. In fact, there are just millions and billions of reasons why we're hearing about big data. Of course, a lot of it has always been around. It's just that now we have the tools and technologies to really leverage this stuff and use it and do things with it. But the topic for today is actually very interesting. So here's a nice little graphic just to absorb as we're talking about this stuff. So combining data sets. The topic for today is connecting the dots with data mashups. And, of course, we have Tableau software in the briefing room today, which I've known about for quite a few years now. And really, right out of the gate, they had some very powerful technology for mixing and matching data sets. And the interesting angle we're going to take today is how you can mix and match not just your traditional types of data, but, for example, if you look at things like supply chains, or you look at all the various things in healthcare that people are trying to deal with, or any of these other industries, if you can find ways to mix and match disparate data sets, meaning data sets that are not aligned in what you might call third normal form, right, where you don't have such a clean line of demarcation that separates this one from that one. It's more of a sort of a hodgepodge, and trying to use these data visualization tools is what we'll talk about to reveal insights that would be difficult to see otherwise. So we have a new analyst in the briefing room today. Very pleased to bring in Lyndsay Wise, calling in from Toronto, and she has a new book that has just come out. We'll try to promote that in our next newsletter, Advance, which comes out on Mondays. I think many of you probably get that. If you don't, by all means, go to insideanalysis.com to check that out and figure it out. So Tableau software, they build software, of course, for data visualization, business intelligence, and analytics. And of course, BI is that sort of traditional relational database-driven transactions, customer records, so on and so forth. And then analytics kind of moves into the business space, trying to better understand your unique business. So they really work hard to do all that fun stuff. And someone who knows a lot about that is our friend Ellie Field. She's been in the briefing room before. We're very pleased to have her back. And so with that, I'll just remind folks we will have a Q&A at the end of this webcast. That's usually one of the best parts of the event, quite frankly. So after the briefing, you can ask any question you want, and we will be sure to put it to Ellie. And with that, Ellie, I'm going to hand the keys of the WebEx over to you. Just click on that slide and use the down arrow on your keyboard, and you're ready to go.
Great. Thanks, Eric. Well, I'm happy to be back with you all today. It's always an interesting discussion here in the briefing room. I think it's a good audience and good analysts, so let's jump right in. Eric, you were talking about a couple of things. You were talking about big data and disparate data, and we see those problems in a lot of the people that we work with. eBay is one company that we work with a lot. They have, as you might expect, big data everywhere, and they're dealing with web transactions. So the magnitude of the data that they have is just massive. They're a Teradata customer, and they're also one of these modern companies that thinks that the people in the company should be smart and empowered to actually work with the data that they have. So they have thousands of product managers and other people who need to work with data. And these folks were all faced with disparate data stores, different data types, huge data, in some cases smaller data, and they'd have to make business decisions like, I own the automotive category. Should I be promoting one brand over another, or should I be placing things at this part of the screen or that part of the screen? And they didn't have the tools to let business people make those decisions. What they do now is they actually provide a centralized view into disparate data sources across the organization so that one person only has one hub to go to access all this data. And then they combine all that in one analytics application as well. Another company that's struggling with this that I personally have spent a lot of time with these guys and been out to St. Louis. This is a teaching hospital. It's one of the biggest teaching hospitals in the United States. And again, it's a forward-thinking organization. They actually believe that doctors and nurses can do better with data. Also, their finance people need data. They actually use data across their organization. But you know, their head of surgery is looking at data on different outcomes and different patients and different methods and saying, well, we can use this to actually make patient care better. They actually do a lot of nurse scheduling that's data-driven. It's pretty amazing. So they can do things like if one unit is getting slammed, the emergency room is getting slammed today, they can look across all the other units and say, well, maybe OBGYN isn't having such a big day. They can pull nurses off dynamically and send them to the emergency room or to another unit that might need that additional staffing, and they can do that in real time. They actually do provide self-service reporting for everyone across the organization. And again, like almost every organization today, these guys are struggling with big data and multiple sources of data. Everyone's seen many variations of this slide. I think, in fact, the slides on big data are becoming big data themselves. But it's true, and everyone's seeing it in their business. In fact, anyone just needs to have a website to see this. And website data is big data, typically, if you have a decent amount of traffic to your website, but there's so many other sources of big data out there as well. And the other interesting thing in the data world today that many of you are probably seeing is what Eric touched on, this idea of disparate data. You know, there was one view of the world that all data would converge into Oracle databases or SQL databases or what have you. That's not what's happening at all. What's happening is the proliferation of data out there is driving this tremendous wave of innovation. Big companies, small companies, everyone's looking at new ways to store data. A few years ago, we saw the column store database come out. We've seen a lot of Hadoop and a Hadoop style, you know, unstructured databases come out. There are a lot of different people tackling this in a lot of different ways, and that's a good thing. It's also a good thing that organizations have choices. You may want to put some data into a column store database. You may want to put some data in a flat file, and that might be the best place for it to live. So there really shouldn't be one single data store, but this is contributing problems because now not only do you have to marry data across different data stores, but across different data types. And this is creating a problem where as we're gathering more data and we're becoming smarter about putting that data somewhere so that we can get to and use it, we're becoming less able to go and get and use it. Implicit in both these slides is the rate of change. It is no longer acceptable to be able to build a dashboard and maybe in 6 months or a year tweak it. The business is typically moving fast enough that you need to change that dashboard, or you're dealing with more data, or you're dealing with a new data source that you want to fold into that data. And so the old tools just aren't working anymore. Not only are they typically developer-driven, so these product managers at eBay and the nurses and surgeons can't make changes, but they take too long. You know, you shouldn't need to sit down and write code to change a dashboard. And fundamentally, they just don't support the idea of a data-driven organization where everybody has the data they need to make decisions. So we've done a fair amount of analysis on this. There's a whole science that looks at what people do with data and how they actually process that in their own brains, no matter what data store that data is sitting in. And there's something called the cycle of visual analysis that's been studied by information scientists. And typically you start with a task. I want to know what the most efficient suppliers in my supply chain are. You get some data. Maybe that data is about the prices that they've given you or the volume. You find some structure in that data. You create a view, bar chart, line chart, what have you. You get some insight, but then you start thinking, well, maybe it's not all about price and volume. Maybe it's about on time, or it's about service levels or SLAs. And so you actually go back to a new task, and you go in another circle. At some point in this task, you may share this data with someone, either in a conversation or an image or what have you. And this cycle is actually an iterative process. Almost no data question that's worth asking has an answer. It's very rare today. The answer is 25. That's it. That's the answer forever. There's usually this cycle of getting data, finding structure, creating a view, developing insight, acting and sharing, asking another question and going around and around. And you can imagine that if in various points in this cycle you inserted a roadblock, say 6 weeks wait for somebody else to change your view of data, you can imagine how that iterative thought process slows down and maybe even grinds to a halt, and why that might lead people to stop making data-driven decisions. So just gathering all your data and putting it in advanced data stores is not the answer. It's part of the answer. You need to give people the way to deal with that so that you can actually get value from all the data in these new forms of storage. So at Tableau, what we see our mission is to help people see and understand their data, wherever their data lives, whatever that data is about, and whoever those people are. We believe that anybody can make better decisions if they have data, and so that's what we're trying to do. We have built into our software a lot of speed. We do things like in-memory data store. If you have slow data, you can bring it in memory into Tableau. That helps speed things up. We also connect live to data so that you can actually connect to a database that's been optimized for analysis, like a Vertica or a Teradata, and you can take advantage of that infrastructure investment that you've made. At every point in the process with Tableau, we're looking at speed of workflow, speed of install, speed of accessing data, speed of rendering points. We're always trying to take time out of the analysis process, because that's when you get to that iterative cycle of visual analysis. The other thing that we really believe at Tableau is it's not about one data store. We don't have a proprietary data store. We have a data engine that you can bring data into. It's not designed to be someone's primary database. It's designed to connect to a lot of different kinds of data, whether that data be CSV files in Excel, which is still true of so many organizations out there, or it be big data and very sophisticated data, cloud data. We're starting to add cloud data sources like Salesforce and Google Analytics so that you can connect directly to those very important sources of data and bring those in and analyze them and mash them up next to your on-premise data or your Excel data. This is the kind of thing that really lets people go to the next step, because when someone's doing an analysis about a business problem, they don't really care where the data is. It's somewhat beside the point. Where the data is simply a way to help that person do an analysis. So that person shouldn't be concerned with the questions of where is it and how do I join it? Do I need to do a data warehouse to bring this data together? They should just be able to reach out, connect to different data sources, blend them in the same view, and go forward. And we'll see a demo of that in a little bit. And then I've mentioned this throughout, but another thing that we think is very, very important, and we try to build into our products, is the idea that this really is for everyone. We talked about the nurses and the surgeons and the doctors and product managers. The idea that data should be contained in this priesthood of people who can access it and work with it, and they have special skills, and they're going to hand down the answers to everyone else, that just doesn't work anymore. To do this, we do things like make the product as easy to use as possible. We're constantly doing user research and trying to make the product more and more intuitive. There's never any scripting needed to use Tableau, and that's the first thing that makes it accessible to everyone. And then thinking throughout the process of how to use different data, how to help people use data, how to help people learn to use data, incorporating best practices from information visualization into Tableau, all of those things help us help our customers communicate better with data and analyze their data better. Just to give you an idea of who Tableau's customers are, and I won't go into a sales pitch here, but just to give you an idea of the breadth. The reason why I show this slide is because Tableau does let people analyze data across all the different industries in this slide and others. And every one of these industries is struggling with the issues that we discussed of big data and data in different places, and the need to get data into the hands of more people. Every single industry with different data types and different business questions, they're all struggling with those questions. So that said, let me go ahead and go into a demo. Eric, can you let's see here.
Yeah, you just have to.
Can you see my screen now?
Not yet. Now I can. There you go.
Okay, great. Okay, so what we have here is, this is Tableau Desktop. This is the analysis product that you use to create reports and then share those up to Tableau Server. And what we have here is we've actually connected to a set of data about flights. And right now I'm not sure exactly what's in this data set. I can drag the number of flights out and immediately see that there are about 12 million records in this database. That's big data for some organizations, not that big data for many. We'll work with 12 million records here, but in Tableau you can work with hundreds of millions of records. We have people working with billions of records right on their desktop, sometimes in memory, sometimes connected live. But let's look at what this interface can do here. What I just did was I double-clicked on number of flights. Let me show you that again. I can do it by drag and drop. I'll take number of flights and I'll drag it onto the canvas up here. And again, we see that 12 million number. So we know we're working with about 12 million flights here. This is FAA data, Federal Aviation Administration data, by the way. So let's look at when those flights were happening. Let's just try to explore the data and understand it. And I'm getting instantaneous responses here. I'm going to go ahead and dig into the week, and I can look at all of this data, how many flights there were by week over this date range, which looks like a couple of years from about 2009 to 2011. I can look at the arrival delay in addition to the number of flights. So now I can actually see that most of these flights were delayed anywhere between 5 and 20 minutes. And that's really interesting. And it looks like we've got some spikes right here around Christmas time. That makes sense. Maybe there was some weather in the U.S. at that time in June. So that's an interesting data point. Might have been something happening in June where there were higher than normal delays. So I've got some initial answers to questions that I'm asking of this data. Another thing I might want to do is go in and say, well, where were all these flights? So I'm going to go ahead and double-click on origin state here. And I can see where all these flights came out of. Simply by grabbing the number of flights and putting that on size, I can see a different view, and I can see that the higher population states did tend to have more flights. That's not surprising. But since we've been talking about delays, by the way, I just used my handy back button up here. In Tableau, the back and forward buttons are always active, so you can always click through as many views as you want, which is another very important thing when you're making data accessible to everyone, is to give them a way to back out of something and make it riskless to try something in Tableau. So the next thing I'm going to do is I'm going to look at this from a delay perspective. So let me drag arrival delay onto color. And now we have a different view of our map, and we can actually see that orange values are higher delay, and not surprising. Flights leaving out of New Jersey typically have the highest delay, maybe something with air traffic there, and leaving out of Idaho seem to have the lowest. So that's interesting. Let's look at another view of this data. Perhaps I'm interested in this data by airline, so I'm going to just drag airline out to rows here, and I'm going to look at the number of flights. That's interesting. I can see the different airlines here. I can sort. I might be interested in, again, looking at that by delay, so I can drag average delay over to color. And now I'm starting to get some really interesting views. It looks like JetBlue is the highest average delay, and Hawaiian Airlines, perhaps because of the routes that they fly, has had the lowest average delay. And this is starting to be really interesting to me. The next thing I can do is I can actually say, well, I'm sure there's some variability by state. I'm actually going to take state and drag it into the view. And I can do things like swap my rows and columns to get a different view of this data. When I've dragged state in, I can see something really interesting here. I can see that there are a few state outliers even within each of the airlines. For example, Southwest does pretty well across the board, except for this one little area here. For some reason, flying into New Mexico, they have a higher than average delay. I'm going to go ahead and swap those views back. I can sort down, sort up. Everything that you might want to do in a typical analysis task, down to some advanced statistics, is right here in Tableau. Now I'm going to do something really extraordinary. I'm going to blend in different data. And I'll show you the data that I'm blending in. We have some data here. Let me just get it open. We have some data here about the fleet age of these different airlines. Here we go. And perhaps I'm somebody who's worried about flying on planes that are too old. So I can go and I can see that United has a certain number of aircraft and the number of planes and the average fleet age. So while I'm working with a database here in this view, I'm just going to go ahead and go connect to data and connect to that new sheet. And when I connect to that new sheet, I'll just choose the fleet, not the source data. Let me just import all data. When I connect to that new data, it's going to tell me that they've both got airline in common. And this is really important here. So if they've both got airline in common and I'm looking at the number of flights by airline, then I ought to be able to bring out the number of planes that each airline has. And you can see it's still colored by the views in my primary data source. Right here we're working with a secondary data source. You can see both data sources up here in the data window. So what I'm going to do is on the number of planes, I'm actually going to drag those other views off because now we're looking at number of flights and number of planes. And what I was really concerned with was the average fleet age of those planes. So I'm going to drag fleet age onto color for this one. And you can see that the age has been summed across all those different airline types. What I really want to do is I want to have the average. And so I can simply change the aggregation by pointing and clicking. Again, no programming ever needed with Tableau. And I've got the average age across all these fleets. And I can see that there's some older planes here in American. It looks like JetBlue. While they have a lot of delays, they actually have a younger fleet. So if that's something I'm interested in, then I might want to fly JetBlue or on Frontier. I've got some null data here, which is very, very common. But basically, I've blended two different data sources, one a database, the other an Excel sheet, right in my view. And so this is the kind of thing that you need to let people do if they're going to be able to work with the data and answer meaningful questions. Another really important thing that people need to be able to do with data is actually create a dashboard like this one. So let's go ahead and create a dashboard. We're going to make it a laptop-sized dashboard. And we can simply drag the sheets that we've made onto the view. We've got the time trend here. We can drag the map onto the view. We can drag the airline delays onto the view. And I'll just click away these legends for now. I could actually make this one floating and move it over here. And so now we can actually relate data across these views. One thing I'm going to do is I'm just going to zoom in on the lower 48 here to make it a little bit easier to see. And I'm going to use this map view as a filter across the rest of the dashboard. And so now I can click into New Jersey and see what's really the problem over there in New Jersey. I can see Continentals flying a lot, but they're not the problem. Delta, JetBlue, Southwest Airtrain, these are some airlines that are having really long delays typically in New Jersey. And that's really interesting. I can also see the number of flights and so on and the number of delays. And I'm learning right here that here from about November to November of this next year, there were lower than average delays. Maybe air traffic kicked up in Newark again. Maybe there was some weather going on there. I can click into Idaho, our other outlier, and see some other things. You can see that we actually have some high delays going out of Idaho, and you can also see this very seasonal trend. So by allowing people to reach out and connect to different data sources and blend them right into the view and create them in dashboards. And here we've got that data, that second data right in the view with my primary data here. We've been able to answer a lot of questions about the data, about the relationship between the data, and do some quite powerful analytical techniques like filtering right in the view. That's the kind of analytics that people need to be able to do on the fly if they're going to be able to deal with big data and disparate data. And so that's what we keep trying to work on at Tableau and to help people see and understand that data. That's what I've got, Eric.
All right, great. Well, let's go ahead and bring Lyndsay back in. Let me go ahead and hold on one second. Let me take back controls. And for those of you out there who have some questions, by all means, get ready to send them in at any point in time. I just want to give actually I'll hand the keys over to Lyndsay Wise. Okay, good. And Lyndsay, actually let me take it back real quick and I'll put your slides up. There we go. And there you are, and there's your slides. So let me hand the keys to you. And the floor is yours, Lyndsay Wise. Take it away.
Thanks, Eric. So both Eric gave a great introduction, and Ellie really showed off Tableau well because I've also played around with it. So, but to move back to big data, one of the things that I wanted to talk about, which is something that Eric also mentioned at the beginning, is that there's a difference between the way big data used to be used and the way it can be leveraged now. So in the past, essentially, people were really struggling with the concept of what is Hadoop, what's Cassandra, what are all these platforms, and how do I consolidate these distributed systems, how do I deal with complexities in large data sets? But there wasn't really the ability to go further because there was still that struggle to really be able to understand how to leverage all of these different data sources and the complexities and diversity that goes along with big data. Now, however, it's a bit different. So just as Eric said, that now it's really the ability to leverage data, and it's a really important point, is now just simply managing that data isn't enough. You need to really be able to add value and identify on a business level in terms of what challenges exist, how do you identify customer sentiment or what's going on if you're looking at social data or different types of information, how do you really leverage that? And so a lot of organizations are now managing their big data infrastructures using traditional BI or not so traditional BI by developing a data warehouse to store and create analytics, as well as developing front-end business analytics, dashboards, and the like to really be able to create that analytical view to be able to develop metrics and share that information. So if you look at the value that's really been derived from big data, is it's being able to take what was once perceived as a lack of visibility and additional complexities and the way the traditional variety, velocity, and volume is described in traditional definitions of big data, and take that and be able to gain more visibility into what products you're offering, how you're managing your services, supply chain, how customers are, what their life cycle is, what their value is, how they're perceiving products, why things aren't getting across, and then even to be able to take that and look at ROI and how to achieve ROI through forecasting and planning and all of these things, which are obviously things that traditional BI can do, but when you're leveraging big data and really being able to manage issues over time and larger issues, it's interesting that finally BI is able to leverage these data sources and get value out of big data. And the final thing is just that one of the things that I wanted to mention is that, in essence, as Eric said and as I've said, managing big data infrastructures are no longer enough. It's not enough to manage it. You need a way to get value out of your information. And so you need the ability to evaluate BI on its merit in relation to big data management. So it's really becoming a must, and so it's important to evaluate solutions like Tableau, like others, to be able to leverage that back end and be able to take it further so that you're not just looking at information, but actually how you want to get information out of the data you're storing. So I guess with that, I'll start with some of my questions for Ellie in terms of, obviously there are a lot of big data definitions, and you've gone through a lot of what Tableau can do. I was curious that, you've showed this a bit, but how would you verbalize Tableau's sweet spot within big data analytics?
Yeah, that's a good question. At the highest level, I would say that we feel that we should be able to help customers with data of any size. We really think that that's our mission. Now, that said, obviously there's just data all over the map. The truth is that big data is whatever the customer or the person thinks it is. For some people, 1 million records is huge data, bigger than they usually work with. For others, 1 billion records is not that big a deal. We want to help people work with the amount of data that's useful to get answers from analytically in one work session. and that can be anything up to a couple of billion rows. Now that said, you typically want to be able to work with an amount of data that lets you do this kind of interactive analysis. And usually you want to focus, if you have such an amazing, it's such a huge amount of data, you usually want to focus down on one or two questions, or maybe even more, but you want to focus into an area of that data set. So I would say, our sweet spot, there's no particular number of rows that's a sweet spot or no particular data source. What we're trying to do is just help anyone who has data anywhere figure out a way to bring that into Tableau and start that cycle of visual analysis.
Right. And so you talked a lot about the diversity and volume. Do you also deal with different complexities? And I guess that would go further than some of the examples at the beginning. You mentioned eBay and the hospital in terms of, self-service for hundreds, if not thousands of companies. How are other companies using Tableau to address their big data challenges? And does it also go into certain industries that really involve a lot of complexities in their data as well as the volumes?
Yeah, we work across a lot of industries. I'll talk about one as an example because I think it's a really nice indicative example, and that's gaming. I'm not a gamer myself, but I've worked with a lot of the gaming companies, and I'm talking about online gaming companies that are customers of Tableau. And this is a really interesting industry for a few reasons. One, the type of data that online gaming companies are collecting did not exist 10 or 20 years ago. Even though there were computer games, they weren't online, so the companies weren't collecting information about them. Now, every single move that you take in Farmville or a first-person shooter or any kind of a game is collected and potentially analyzed. The second is that data is massive. I mean, the gaming companies are working with these are the ones working with terabytes at a time. In a given game, for maybe a week's worth of data, they're looking at terabytes of data. And the third is that gaming companies and the people at gaming companies tend to be very open to new solutions. So they're trying a lot of different things. They're trying a lot of these new data stores. Many of them are trying Tableau. And what you see these companies doing is a very flexible and very interesting analysis of all of this data and mashing up different data. So you can imagine mashing up gameplay data. So what moves did this person make? How many points did they achieve? When did their character die? Mashing up that kind of data with social data. When did someone share the game? When did they invite a friend? And so you can see how different gameplay events influence social sharing. And of course, social sharing is critical for the survival of many of these games. Same with monetization data. So this person's character died, they got more points, they achieved a prize. At what point did the person decide to buy something from the game? And obviously monetization is also a really important thing that gaming companies are looking to do. And because of the nature of these games and the players of these games, the data is massive and it's changing all the time. I mean, there's nobody who's designed a database for Farmville, right? I mean, the data structures are completely new, the things that people are working with. And in many cases, the data structures are changing quite rapidly as the developers update the game. And so the people looking at that, often product managers, often BI analysts and others, have to be able to deal with this very changeable, very large, very complex data and mash up different data sources. So that's one way that we see people using very large data and different disparate types of very large data. We have examples across many industries, but I thought that going deep on one would be interesting.
No, definitely, and I always love gaming examples because you're right, the type of data they use is really complex. Do you see, you mentioned a lot of what they do with it. Are they also able to kind of project in terms of making suggestions on what types of, let's say, games they should recommend or different offerings to give to certain customers?
Yeah, they do. They do use it. They do use it to design products as well. And one of my favorite examples is I won't mention the company, but somebody from one of our gaming customers came and was talking about they actually released a virus in a certain game for the players. Of course, the player would get a virus, and the virus would spread as it would in the real world. And at first, the virus spread fairly slowly. It took about a week for everybody to get the virus in the game, and people recovered. Most people recovered. I guess some of the characters died. Well, they noticed an increase in sharing during that time. So the virus was successful from a game development point of view. Well, they tried it again, and based on the data they had seen, they actually accelerated the pace of the virus. The virus then spread in a couple of days instead of a week, and the sharing doubled. in that time. So there was something about the pace of this virus, and for them, something like a virus or some kind of a new event is a product innovation. So that's one example. You could also imagine looking across a portfolio of games and saying, well, these games are performing very well with this demographic, which is another thing gaming companies do a lot, is this demographic analysis, and then targeting more games at that particular demographic.
Great. And so you've given some great examples, and obviously the next question I'm asking in terms of, there are a lot of vendors in the market, and obviously some of them do similar things to Tableau, some do different. What do you feel for Tableau is the real differentiator and value proposition in comparison to how other similar vendors will address big data challenges?
I think there's a couple. The first I would say is speed, and again, it's speed at all aspects. It's speed of installing and deploying. We see that many of our customers are up to date on the latest release because upgrading to a new release is not a massive, painful exercise. It's quite straightforward. That's one aspect of speed. Speed of being able to develop views. So many of our competitors still, even if you have a web interface that executives and others can work with, you still need the developer to modify or create a view, and that slows down the process quite a lot. So speed is one aspect. I think the other aspect that we really compete on is choice. And there's not only the choice of the different data stores that you may want to use. So again, we're not saying, hey, to use Tableau, you have to have your data in our proprietary data store or this data store. We're saying we want to work with whatever's out there, and whatever our customers are using, we want to work with that. And not only that, you have the choice to bring that data in memory if you want to speed it up and deal with it locally or offline, or to connect live. And customers do that. They blend live data with in-memory data. They go back and forth. They'll take data offline and bring it in memory, connect back live when they get off a plane or get to a good connection. And so it's that ad hoc, on-the-fly ability to choose not only the data I'm connecting to, but the way that I work with it.
Right. So in terms of working with data specifically, and I'll say this because I've played around with Tableau and it is really user-friendly, but what about for business users in terms of creating new calculations and doing that? Is it really easy for them to do that on their own, or do they need more of a technical resource to be able to do that for them?
Yeah, it's I didn't show this in the demo, but it's still a right-click kind of point-and-click experience. Basically, you create a calculation in the data window, and you can pull it out like any other field. The calculation language is very similar to Excel. So if you can do calcs in Excel, with some of the formulas in Excel, you can do them in Tableau, and we have the help on the formulas and so on. So anybody who's a decent Excel user can create calculations and use them in Tableau. Right.
And so you talked about obviously faster data access and showed that in terms of live connections or in memory. Are there different limitations that exist? Does it depend on the platform that companies are using? Does it differ based on that, or is it simply, you've optimized the system so much that shouldn't matter? How does that work?
Our in-memory in-memory technology has been around for a while. Our engineers worked with some academics and actually came up with a really interesting way to do in-memory. And not to get too technical, but often in-memory just uses RAM. Our in-memory actually works across the entire client system. So it'll work on everything from cache memory and RAM, which is your fastest and smallest memory, all the way down to disk. So you can theoretically have as much memory on your local machine as you have disk space. And then as you start having in-memory data on servers, again, servers are obviously, usually quite high-powered. So you can actually keep quite a lot of data on a machine based on the technology of using all the memory on the machine. So you are ultimately limited by the size of data on your machine for in-memory, but then again, if you're using very large data, you may be wanting to connect live to something like a Teradata system. And if you're connecting live, then there's no limitation beyond the limitation of the back-end data store.
Right. Okay, and first off, I'll apologize to everyone because I've kind of gone a little bit out of order with the questions just based on what you're saying, Ellie. So I'll move back in terms of, we talked a lot about differentiators, and you mentioned, I kind of asked some questions based on what you said, but obviously you've talked a lot about companies that would want, are there specific business cases when a company would not want to use Tableau to manage their big data, and kind of what would those be?
Sure. Well, the first thing is that you don't really use Tableau to manage data. We think of ourselves as kind of the neutral player amongst a lot of data stores. So not many customers are out there using Tableau to manage data. You can use it to manage metadata and to make data available, to make data available centrally for different people to access. So I just want to make sure that you've got that distinction. You know, we've seen use cases for Tableau in a lot of different places. I'm not trying to avoid your question, but I mean, sometimes people have existing reports set up, and those reports are working great for them, and they want to just keep using those reports. We see that a lot, and sometimes those customers then want to use Tableau for ad hoc analysis or prototyping new dashboards or reports. So, I mean, there's different aspects out there of what you might be wanting to do. I think if you've got something working, we rarely recommend someone to rip and replace. You know, that's usually not a good solution for anyone. So that's what I would say. But almost anyone who's using data, you know, even Excel sheets and things has a use for Tableau.
Right. So are there specific limitations though, or more of, I mean, what would you think? We've talked a lot about the benefits, but do you see challenges in terms of using Tableau, or what would they be for organizations?
You know, challenges that our customers see are often getting people to think differently about data. We often see challenges where you might have some people working with Tableau and others saying, well, you know, you can't have access to the data. So that's sometimes been a challenge, just getting access to the data for people who want to work with it. That can be a challenge depending on the approach of your company to the security of its data and the access that your employees have to it. That could definitely be a challenge, because Tableau is about putting data in the hands of more people. So if you don't want that to happen, that might be a place where you don't want to use Tableau. But that's probably the biggest barrier that we see, is when people can't get access to their company data.
Right. And do you actually encounter that a lot, where certain of the data is kind of limited in terms of how organizations want to deploy it to their users?
You know, everyone has security and everyone has user roles and so on. Our data, our analytics support user filters, so you can actually say which users or which groups can get access to different data types, and it also enforces row-level security in a database. So, for example, if I don't have access to the data in SQL Server, I won't be able to see it in Tableau. So there are ways to enforce security. Now, that said, there are some organizations out there, sometimes government organizations, sometimes others, that are just philosophically don't want their data in the hands of their employees. And in that case, you know, there's still BI analysts or people who can use Tableau, but in that case, it's just harder to get the full value of Tableau.
Right. And more on a broader question, because you deal with so many customers and different types of companies, what type of trends are you seeing in relation to customer use and transition from just storage to actual analytics and being able to get value out of that data?
I'm sorry, say that again.
Like the types of trends that you're seeing in terms of customer use beyond just the examples. Are you seeing specific trends in the market of how organizations are leveraging big data and what they're trying to do with it?
You know, the biggest trend that we see, and this has changed over the last few years for sure, the biggest trend is an acknowledgement that you actually can you can give people data and it will be okay. And I think the mindset is shifting from we've got to lock it down all the time, and employees don't have the sophistication or the security clearance or what have you to get data. We're starting to see organizations say, you know, wait a minute, we've got to make an intelligent decision here. We've got to empower our people, and we're not going to be able to empower them unless they can get data. And so that's been really the biggest shift that we've seen. We've also seen, as I think everyone has, we've seen a shift towards using Hadoop-style databases, to looking at unstructured data, to being more open to new data stores. We've definitely seen that shift as well.
And how does Tableau deal with unstructured data and analytics per se?
Yeah, Tableau, so we work with Hadoop via Hive. We work with several Hadoop distributions. And one way to think about it is structure on the fly. So Tableau does work with a structured data format, but when you connect to Hadoop or another unstructured database, what you do is you basically explore the structure by creating different table types in Hive, and then Tableau connects to Hadoop via that. Now, most of the time you're going to want to create an extract if you're connecting to something like Hadoop because of the latency.
Right.
But it's very powerful, and actually I've done this type of analysis where you connect to Hadoop, and when you're working with unstructured data, it's the classic use case where you don't know what you're looking for until you see it. So you create some ad hoc structure in a table or a few, and you analyze those, and it leads to more questions, but you realize you didn't bring the right data in, so you go and you create a different ad hoc structure, and you bring that data in, and you continue on doing that. So that's how Tableau works with unstructured data.
Right. Okay. And in terms of, because obviously there are a lot of different people listening in, and they probably want to know if they're interested or evaluating Tableau, what are the types of things that they need to know or prepare for in advance to get the system up and running? Obviously, you showed how simple it was, but are there certain things or certain preparations or steps that they need in advance?
It depends on. It depends on your environment, what you want to do. I think having a well thought out data architecture is always useful. Tableau can connect to anything, but if your team has sat around and thought about where data is going to live and who's going to have access to it and what speed it needs to be at and so on, that's usually going to be beneficial. That's one thing. It depends also whether you're talking about desktop or server. Both install in minutes. At its simplest, if you wanted to download and install the trial, you could be up and running with both in a few minutes, literally. Most organizations want to do a pilot. They want to roll out with a few users at first. They want to make sure that their metadata their data architecture is in good shape, and so on. So that's if you really want to be successful with Tableau, the advice that I would give you is to define one project to start with, and then roll out for the team that needs that project, and then roll out from there.
Right. Okay. Eric, I see a lot of questions, so should I be passing it back to you?
Sure, I'll go ahead and dive right back in here. And we do have a lot of good questions. Thank you so much for sending these in. So you kind of talked a little bit about, I've got a couple questions here about Hadoop, but can you talk about what kind of connectivity you have to Hadoop?
Yeah, sure. So in Tableau, you can actually connect to, we connect to Cloudera's Hadoop distribution. Okay. We connect to Hortonworks Hadoop Hive, via Hive again, MapR, and then we connect to a number of other different data types as well that are at least new style. We're also always looking for new data sources that our customers are using. We're always creating new connections. So those are our Hadoop connections right now, but we're always adding more.
Okay, good. And if you want, I can turn it back over to you if you want to do another demo or dig into stuff, but it's up to you.
Yeah.
So let me just go
I'd love to, I would love to, let's see, let me show my screen.
Because that's some of the best stuff here.
Yeah.
Click on the quick start way at the top left-hand corner. There you go.
Yeah, and share my desktop.
So
what I've got...
Oh, go ahead.
What I've got open here is our connected data dialog, which I showed briefly as I connected to that Excel data. But all of these... Yeah, so all of these, obviously you can open data that's stored on Tableau Server, and this is one of the ways that you can give access to people all across your organization, access to the same data. You can store it up on Tableau Server. But, we've got Actian, Aster, Cloudera. I won't read through them all for you, but you can see it's quite an extensive list. We've got some of the more common ones in there, Oracle, of course, SQL Server, Excel. And so we're always looking at what people are using, and we're always trying to make access to data better in Tableau. We also have an ODBC driver, so if you really can't find anything, as long as your database is working with ODBC, you can use that.
Yeah, that's an impressive list right there, and I'm guessing that you guys are constantly updating that. Someone is keeping tabs on when new versions.
Always updating that. Yeah, we're always working with new versions. When you see something in this list versus ODBC, what it means is that we've actually optimized for that connection, and we're trying to use the native features of that database. So, for example, with Teradata, we use query banding. With SQL, we're doing some performance optimization. So it's not just that we connect to those, because, again, we connect to almost anything with the ODBC, but that we're keeping up on the new versions. We've tested the connection. We're optimizing for that connection. So that's what all of these connections in this list mean.
Yeah, that's impressive. Okay, good. Let me just kind of dive into some of these other questions. Kind of an observation from one of the attendees, but I'm sure you can speak to this, just noting, yes, it's a great tool for visualization, but you still need someone to massage the data properly. Things like averages. I mean, you really do have to, as any kind of business user, think through things like averages, because they can be fairly misleading. And I'm sure that's something that you just routinely talk to people about, right?
Yeah, it is, and actually, I love that question, because I noticed there was something about weighted average on our flight age, and I think that's very true. It should be weighted average there, and you do need someone to think through this. One way that you can do that, it actually goes back to what Lyndsay asked about calculations. So over here in the data window, you can actually create a calculated field, and you could call something. I'm going to make something up here, but you could just say, profit. If you had a definition of profit that was very specific to your organization, and a lot of price-sensitive organizations do, in fact, have this. You could create a definition of profit using, again, some of these functions that we have here, date functions, et cetera, and you could publish that up. I'm just going to pretend that we made a calculation there. You can see profit here. You can publish that up to Tableau Server. This calculation actually becomes shared metadata, so that as people download this connection, this flights connection, profit comes with it, and the organization-wide definition of profit comes with it, so that you're actually providing some of that intelligence to business users. And that's part of what I mean by information architecture. If there is things, you don't have to do that, but if there are things that you want to standardize organization-wide, you can do that via Tableau to help business users get that stepping stone. And yes, there is also a role for a data scientist or an analyst to look at things. Ad hoc analysis is great. You definitely want to give it give it a pass if you're going to be making big decisions on it. Let different people look at it, and then use things like metadata and calculations to give people the helping hand to make sure that everyone's working from the same definition of a field.
Sure. Okay, I'm glad you mentioned that, because that was another question I had, is what does that metadata management layer look like, and how, for example, does Tableau know, okay, this field name actually is the same as this field N1 in another database? Obviously, you have different column headers on different data sets, and a lot of times those align to very specific things. Is there sort of a management environment for dealing with those different issues of nomenclature?
The management environment is actually Tableau Desktop, and the reason why we do that is trying to make it as straightforward as possible. So imagine I were the administrator here. This data set is actually published up onto Tableau Server. We can edit the connection and see that.
Right.
And what I could do here is I could create that calculated field. Maybe I can create another calculated field, and then if I republish this data source, and this is 12 million records, so it would take over a minute. So I don't want to do it right now. But if I republish this and and lock the data source so that people could extend it but not change these calculations, these two calculations I've just created would become metadata for everyone in the organization who connects to this. So that's how organizations do it. They publish a connection to data or an extract of data. That connection includes the metadata right in it. So as a business user, I can just say, hey, I want to go get my sales data, and I go and connect the sales data on Tableau Server, and that includes for me all of the calculated fields that make up the metadata for my organization. You can also do things like define field names or define comments for fields to help people understand what's in the data.
And you kind of talked about this already, but there's another very specific question about just one of the attendees notes in the example of merging in the jet age with the on-time stats. The airline was a common key. How does Tableau identify the common values? Is that manual, or is there any kind of AI, artificial intelligence, going underneath to kind of help you through that process?
Yes. So the answer is actually both. It starts out with some artificial intelligence. Here you'll notice that the field airline is in common in both data sets, airline here and airline here. Tableau detected that, and you can see the little chain key here. And so it said, hey, you know, you've got airline in both these data sets. I'm gonna guess that you want to blend on airline. Other common fields are date or category, and if Tableau sees those common across data sets, they'll just create a blend there. You can always go into relationships here in Tableau, and you can actually change that. So I could edit this connection here. I could make it custom and just add a connection or edit this one or remove it. And so that's very common with Tableau. We usually try to guess the right answer, and that makes it easy for people to go and just keep going. But you can always change things as well, because you often do want to go and customize something.
Yeah, that's very interesting. What about data streams? We're hearing more and more about just grabbing live fire hose type streams of data. How would Tableau deal with something like that?
You know, we do that a lot ourselves with Twitter data. Right now what you do is you basically will drop it into an intermediate data store like SQL or CSV or something and connect to that. We are actually adding a data extract API in 8.0 beta, and many of our customers are testing that right now. And that's an API that lets you basically stream data straight into Tableau via an API.
Okay, cool. APIs are definitely catching on. I think we're going to see a whole lot more organizations using data streams in real time and mixing and matching multiple data streams. So that's interesting.
Yeah.
What about, obviously
Absolutely.
you do lots of stuff with maps. You're probably familiar with Esri. Can you incorporate directly with Esri style maps or other kind of GPS systems?
Yeah, we give you the option. We don't incorporate that directly with Esri, just to answer that question. But we do give you ways to basically use WMS servers in your data. So you could, if you had, for example, a weather server and you wanted to see real-time weather data underneath this map, you could connect to that and just put in the URL of the server for your WMS, and you'd be able to see that data right on a map. So we support that level of data. People doing analysis in Esri are often doing really, really exacting location analysis. We try to make our maps work for about 95% of the market, you know, most of the business analysis that's out there. If you're plotting where to put the next cell phone access tower, you probably need Esri.
Interesting. That's a good piece of information right there. Okay, good. And here's another good question. And I know I see you've got some standard calculations that this comes bundled with. How detailed do those get, and do you have now any industry-specific templates for various calculations, like logistics comes to mind, for example, anything that comes packaged with the solution for various verticals?
First of all, to answer the question, the calculations are quite extensive. You can see the types of functions we have here, some of those Excel-like functions, aggregations, and so on. We also have what we call table calculations, which are extremely powerful ways to use the data that's in the view itself. We include parameters, so you can actually set up what-if scenarios in your data by defining a parameter. That said, we do not provide templates for different industries. We do provide a lot of different examples for industries on our website. So if you go to our website and go to the solutions on our website, and let me just show you that, then you can actually find a lot of different examples. Here, let me show you. So for example, if you wanted to look at let's look at supply chain, because that's actually got a WMS server. It goes to one of the other questions. So here you can actually go into a supply chain view and see a view that somebody's created for supply chain. And this view on the right is actually drawing from a WMS server. So we know what the weather of this area is, and this is someone trying to determine the best route to go from A to B. But you can use these examples, and they're all drawn from real customer examples that we have, to go and think about what kind of analysis you might want to do.
Yeah, and I know you've got this Tableau Public project too. Can you talk about that for a second?
Yeah, sure. Tableau Public is a really exciting project, which is a free version of Tableau. And what it does is it's something that's used by a lot of journalists and others, free forever. It's a cloud that they can publish to in the sky, as well as a free download. And the idea is that there's a lot of data out there that is important to us in our public life, government data, sports data. You can actually see this here. This is something out of Latin America that was published by ESPN Sports. And basically, journalists and others, bloggers, people who are just interested, are using this tool to understand what's going on in different areas of public data. Now, it's limited in that the data does need to be public. You wouldn't want to put your corporate data in this. But it's giving you some analysis of different things out there. And sports is a great use of this. I love it when I see local government data, other public data in Tableau Public, because when you think about something like local government data, often it's a private citizen or a small blogger who doesn't have the resources of a big data team at a huge newspaper to go and do some analysis, but it's really important data that's out there. So we see data on economics and on politics. We saw a lot of analysis of the election, and you can actually go to Tableau Public and just click around and find different visualizations that have been published by the community.
And I'm guessing that you guys really get excited about the collaboration side of this equation, specifically Tableau Public, just kind of like you said earlier with unstructured data. It's a different story than with traditional structured data where you're doing queries and you know the answer you're trying to find. With unstructured data, you really don't know what you're trying to find. So that's where the whole discovery side of the equation comes in, right?
Yeah, and even with a lot of structured data, I mean, one of the truths of big data is that, we always say it's hard to see the answer in any more than about 50 rows and columns of data, right? If you've got 50 rows and columns of data, your eyes start to glaze over, and that's just being human. That's not being good or bad at math or anything else. We need to see data in pictures to be able to assimilate it, to understand it. And that becomes even more true with big data, because if we can't process 50 rows of data just by reading down, how are we ever going to process 50 million rows or 500 million rows of data? And a lot of times when you get that data, I mean, think about getting a huge dump of web store data in. You don't really know what's in there. I mean, you know some things to go look at. Let's find out what the average order size is and so on. But when you really start digging in and exploring the data, you don't really know where you're going all the time. You're just trying to understand what's in that data set. And that's really interesting in both structured and unstructured data.
And I guess I'll throw one last question out to you. I've seen in some of the tools that I use to do online marketing, once in a while there'll be some kind of a glitch, and I'm guessing it's just some piece of bad data that worked its way in there, and a pie chart will suddenly get all skewed and just start going in different directions. What happens when some false value comes through? I mean, you talked about null sets, but what about values that obviously don't fit within a particular structure? Is there an error message that you get from Tableau, or does it warn you that it thinks there's something wrong?
Null values won't come in, but the other thing you can do is you can always just exclude values in Tableau, and it's a point and click. Like, for example, if I thought that this data was really poor data, I could just exclude this data, and I would get it changed. Or if I knew, for example, as I do, that some of these Delta and Northwest have actually merged, I can just group those right in my view. Again, it's all drag and drop, and it looks like I broke the number of planes on doing that, but it's all a drag and drop environment, and you can exclude, you can keep only, and so it's sometimes dirty data is not dirty data. Sometimes it's outliers. Sometimes it's really dirty and it's irrelevant. You want to get rid of it. So sometimes that's part of the analysis task, is actually cleaning your data, and it can be valuable to do that as part of the analysis task. Because you may find that you've considered your outliers to be dirty when in fact they're the most meaningful values that you have.
Okay, great. Well, folks, we've kind of burned right through that hour. Again, always a fascinating discussion with our friends from Tableau. A very big thank you to Lyndsay Wise in her very first briefing room. I'll just kind of throw our slides up here in the end. And, of course, big thank you to all of you folks out there for bringing us your good questions. So with that, I'm actually going to probably just go ahead and call it quits here, folks. Big thank you once again to Tableau Software. Big thank you to Lyndsay for her time today, and to all of you out there for your time and attention. Stay on top of all that's happening in this industry by checking out InsideAnalysis.com. We have lots of fun things coming down the pike, so we look to see you on our website and our future events. So with that, I'm going to end the event, folks. Thanks again so much for your time and attention. Take care. Bye-bye.